process. Okay. Oh well. No, that's right. We'll see. Hello. I'm Jakob Bornecrantz. Let's see. That's important. Okay. Anyway, it seems to be speaking a frame. Okay. Anyways, I'm Jakob Bornecrantz. I work for Collabora. I'm doing XRE stuff. Part of that is running 2D things, so I'm going to talk about it. Sorry, it's picking me up that it's missing slides, so always. Anyway, I'm going to talk about cross-processing, sharing, and direct mode. So give a little bit of introduction and talk about them separately. To wrap up, now I'm going to talk about why. Why would you do sharing? So mostly that is for security, especially inside browsers where you have to run things in different processes, completely lock things down, and then you have to still have to get the different processes. And it's not just between Vulkan and Vulkan, you can also do Vulkan to Vulkan here, where this becomes a sort of it becomes a sort of it becomes a better like unified way of doing sharing between different APIs. Yep. So I'm sorry, it's skipping slides. So yeah.
This is the slide that I downloaded.
Okay.
If perhaps.
So I see the slides. Sorry. No. Oh, sorry. Okay. What is that?
Basically, slide number 6.
Okay, yeah, that is cool. Sorry. It's
which slide?
Yeah, no. You go on. Yeah.
You can use the window. Theory shoot.
So how do I bring it up?
Yes. So first we do screen. And then you
Okay. So why direct mode? Usually we want to bypass the compositor. Almost entirely used by VR things, like Steam VR runtime and things like that. It's Vulkan only. Unfortunately, I saw the new extension that was released that probably will completely replace this. So I just saw it today. So that will be a bit interesting to see how that turns out. But why am I specifically doing this? So I'm working for Collabora, as I said, and I'm working on building a OpenXR runtime, completely open source, mostly for Linux. But in the future we'll look to extend it more. And we do have a compositor, and it does all that thing because we want to run the compositor in a different process, and we also want to have direct mode access to the hardware to get the needed performance that we need, especially bypassing the other compositor, the OS compositor. I'm going to talk a little bit about cross-processing sharing. So the process is very simple. You create the handle, you create the image or buffer, get the native handle, you wave your hands and get it to the other process, and then you use it. Whereas if you're doing cross API sharing, just get the native handle and then use it. So what can we share in Vulkan? We have 3 things: the fence, the memory, and the semaphore. And they are all under each extension, where you have KHR external thing and then a platform. So these are the ones that are lined up. So what actually are we sharing on what's the platform? So on Linux, you share a FD, and on Windows you share a handle. There's also on Linux a subtype called DMA-buff, which allows you to actually access with various native Linux API, whereas the normal FD is just opaque, you don't really know what it is. And these are the extensions that lines up with, and you can only share DMA-buff with memory, so but the other things are available for semaphores and fences. Yeah, so I'm gonna commit a completion thing and have code on the screen, but it's very simple. You first create your image with a dedicated zone memory, so it knows that you can do the necessary allocation, making sure that it's shareable. You then create the allocate device memory, again with telling it over and over that this is really dedicated memory and for the specific image, and you want to export it. And finally, you actually get the FD. This is the little thingy that you actually want. And then you use the FD, and again, all this code around it to actually use it down there. So any gotchas? From what I found, the fence and semaphore might not be shareable on all drivers, so you can only really share buffers reliably, at least on the platform that we care about. And NVIDIA doesn't have the DMA-buff one, it just has the variant, the opaque one, and which is just use the opaque one. I have looked into the Mesa drivers, the Intel and AMDs, and they do a little bit differently depending on if a buffer is or image is shared or not. So there might be performance issues, especially with sub-render paths and early flushing, but I haven't seen an issue yet. So hopefully it should work as well. So a little bit about direct mode. You need the base extension, which is KHR display, and that's the next extension. And the process here is similar. You find the display, you find the mode, you find all the little nitty-gritty details that goes into actually setting the mode. You acquire that display, and then you set the mode to bring it all up. There is unfortunately no driver that I know of that exposes KHR displays on Windows. So, but there is a Windows-specific API for DX12, and you can probably use some kind of sharing to actually get in there. And those are not that API is not hidden. If you might have heard of the secret hidden APIs that the VR, like Steam VR and Oculus runtimes are using. And on Linux, unfortunately, theirs are a little bit different between the Mesa drivers and the NVIDIA ones. So we need 2 extra extensions, and we have to unfortunately talk to X11. Those are probably that's probably older than everybody in this room. We put together. But we can use the new XB API, and hopefully none of you have actually had the pleasure of using any of that. So what we usually do, we get a VK display, or the common thing between them. You get it somehow, we different between the two. Then you search through all of the mode, played, and more stuff that needs going in, like surface formats and all that degree of detail. You create a surface, and then you continue to use it like you normally would in a normal application. So for Mesa, we talk to the X server and look for a display with a non-desktop flag, which basically means if you ever plugged in in the beginnings of time, a VR headset on your computer, it will actually bring out the desktop there, and it will see like a very distorted desktop. but the flag there makes the driver not look up first. So this is very much for our thing, but yeah, we want to actually drive it. We need to find the output where the user has plugged it in. Then we go from the X thingy to the Vulkan KHR display thing. And then we call 3K require excellent display. It actually takes the display. Similar for NVIDIA, but we only can use, unfortunately NVIDIA hides the display completely from the X server. So we need to look through all of the Vulkan abstraction of the displays, look at the ED name and try to figure out their exact one. And then we get it in the same function again. And then we're done. You got just yes. The code is not really, or drivers doesn't really check that you're doing anything right with Vulkan, so you can very easily grab your whole desktop and it will come back up and you will hit the stock. And I said NVIDIA will hide the non-desktop display on X completely, so you have to do a bit of wrap up a little bit. I really like this picture, so I'll try to include it in my talks, especially about XR. If you didn't know, if you actually remember the second movie, he's actually using his glasses as a AR device, so he actually gets information from it. I do actually like the third movie because unlike other topical things now, they actually know how to close out the movie nicely, or the series nicely. Okay, sorry, it's I think there's a bug with one of the slides, unfortunately. So, yeah. If you have any questions, please ask. Just ask about anything. Can do it like this. Sorry. Yeah, as you can see, there's something wrong with this slide. It should be me on there. So never mind. Why is it going off? Yeah. Oh, I've got a question. Go ahead.
Yeah, I mean, so this is for X11. Is there a way to do anything in Wayland?
Not right now. We have extensions for Wayland that allow you to go through the outputs and actually grab it and get direct mode control to it. So we might say sometimes in the future, hopefully. Yeah. Yeah.
Do you have any experience sharing resources between processors on different devices? So say you had two graphics cards on the same motherboard, how would you share a buffer between them?
With a lot of pre.
Yeah.
Yeah. No, not personally. I know there's like things like Optimus or NVIDIA, Intel. Yeah, not personal experience, but it should be possible. That's basically what DMA has been all about, is to share things like between a GPU and a video device. So. They have to know the formats really well, or put it in some sort of a linear format. So. Yeah, so feel free to come to me to talk about anything. What we can see here is I like a lot of other stuff, so I really like XR, VR, and AR. Trying to build a community around there, open source and everything. I do also like open source and FPGAs, and also if you happen to be really retro Amigas, feel free to talk about that. And yeah, anything. Yes.
I'll see the
Yeah, it's working. So I made it in Google Slides. That's probably the reason why it's not cooperate. Yeah. Right. Thank you, and enjoy your break.
We're starting in half an hour?
Alright.
The sheet says we get a half-hour break.
Don't tell me.
Hello. I am not Gemma. We're going to have an early half-hour break, so start again at around past. Some more chatter. Fix Vulkan.
And it's